Hello everyone, this side Sailesh. I'm a faculty at 9 Education Vidyanagar, and today we are going to have a paper discussion for the part is 3 of the subject physics. Let us proceed. Okay, so in this particular question, let us first calculate the limiting friction because we want to check whether the body is going to move or not. So what do you think the value of the limiting friction will be? The formula of the limiting friction is mu s into normal action, and the normal action is mass into gravity, its own weight. So what is mu s? Mu s is 0.02 into mass is about 1 kg into ton, which is about 0.2 Newton. Now let us calculate the net force that will be experienced by the block due to the external forces. 3 Newton on the right side, 2 Newton on the left side. So the net force will be 3 minus 2, which is 1 Newton in the right side direction. Now it is quite obvious that this 1 Newton force is greater than the limiting friction. So which friction is going to act? The kinetic friction is going to act in this particular situation. And let us assume that the acceleration of the body is A. First, let us calculate the kinetic friction. What will the kinetic friction? It will be mu k into mg. Mu k is 0.01 into 1 into 10. That is about 0.1 Newton. Now let us write down the FBD equation of the above picture. That will be 1 Newton in the right side direction minus 0.1 Newton due to the friction is equal to the mass of the body, which is 1, into acceleration of the body, which is A. And from this, we are getting that the acceleration of the body is about 0.9 meter per second square. So what is the answer? The answer is option D. Next. Okay. So in this particular question, let us assume that the boy is standing on this weighing machine. Now, initially, when the boy was at rest, the weighing machine was measuring the weight of the boy. And what is the weight of the boy? The weight of the boy is about 400 Newton. Is about 400 Newton. Now, I can write down this weight as mass into gravity. Now, gravity is about 10. So from this equation, I can get that the mass of the body is, or the mass of the boy is about 40 kg. Right? Now, when the boy starts to jump, the machine reads 600 Newton. Now, what do you think that 600 Newton is? It is nothing but the normal action that is exerted on the boy by the weighing machine. And that normal action is how much? It is about 600 Newton. Now, let's say that the acceleration of the boy is A in the vertically upward direction. From the FBD, we can straightforwardly write it down that 600 minus 400 Newton will be equal to mass of the body, which is 40, into acceleration of the body, which is A. And hence, the acceleration of the body is about 200 by 40, which is about 5 meter per second square, which is about 5 meter per second square. Answer is option A. Next. Now, in this particular question, it is quite obvious that within 20 second, the body is completing one round. And we have to calculate the displacement of the body after 45 seconds, right? Okay. So for every 20 seconds, it is going to complete one round. That means for the first round, it is going to take 20 seconds. For the second round, it is again going to take a 20 second time. So total time is 40 seconds. And after covering two rotations, it will move forward, or it will move along the circle for 5 more seconds. For how much more second? 5 more seconds. That means within 40 seconds, within 40 seconds, it is going to conduct two complete rotations. It is going to conduct two complete rotations. And after that, it is again going to move for 5 seconds, right? Now let us apply the unit method in order to find out how much additional angle is it going to move within that 5 seconds. Within that 5 seconds. Okay. Achha. So it is completing in 20 seconds. In 20 seconds, it is completing one rotation. And one rotation is equivalent to 2 pi radian. One rotation is equivalent to 2 pi radian. So within 1 second, it is going to complete 1 by 20th of the rotation, 1 by 20th of the rotation, which is about 2 pi by 20 radian. Now, within that 5 seconds, how much angle is it going to cover? It will be 5 by 20th of the rotation, which is 1/4 of a rotation, or 2 pi by 20 into 5. 2 pi by 20 into 5 radian, which is about pi by 2 radian, which is about pi by 2 radian. That means if this is the circular path that the particle is following, initially if the particle was over here, initially if the particle was starting from over here, then for the first 20 seconds, it is going to complete one rotation. In the second 20 seconds, which is after 40 seconds, it is going to complete another rotation. And after that, it is going to travel an angle of 90 degree for the additional 5 seconds. For the additional 5 seconds. That means its final position will be somewhere over here, right? And now we have to calculate the displacement. Now we have to calculate the displacement, which is this one, S. Okay. Now let's see how I can calculate this. So I already know that the angle that is covered by the body within that 5 second amount of time is 90 degree. So if this is R and this is also R, with the help of Pythagoras theorem, I can straightforwardly write down that S will be equal to how much? Root over of R square plus R square. That will be R root 2. That will be about R root 2. So our answer is root 2 or option B. Now, next question. Okay. So in this particular question, dv by dt is given as minus 2.5 root b. Now, after looking at this differential equation, it is quite obvious that we need to apply separation of variable methods, right? So let us apply. Now, I can write dv by root b, I will bring root b over here, is equal to minus 2.5 dt. Now let us proceed with the integration. Now let us proceed with the integration. As in the question, it has already mentioned that the body is going to deaccelerate. That means its velocity is going to decrease. So it is going to decrease from where to where? Its initial velocity was 6.25. And as we want to calculate the time it takes to come to at rest, its final velocity will be 0. And the time taken will be from 0 to t. The time taken will be from 0 to t. Let us proceed with the integration. The integration of 1 by root b to b, 1 by root b is 2 root v. And the limits are from 6.25 to 0. And this will become minus 2.5 into t. Now, if you'll put the upper limit and then the lower limit, you will get the answer as minus 2 into root over of 6.25 is equal to minus 2.5 into t. So what is the value of t? Minus minus cancel out, and what is the value of the t? The value of time taken will be 2 into root over of 6.25 by 2.5, which will be about 2 seconds. Which will be about 2 seconds. Now the answer to this particular question is option B, 2 seconds. Next. Now, in this particular question, we have to calculate both distance as well as displacement. And which graph is given? The velocity time graph is given, right? And we like if you want to calculate the value of the displacement or the value of the distance from velocity time graph, then basically we have to calculate the area. First, let us calculate the area, right? Now let me try to calculate the area of this particular region, which is nothing but a trapezium, which is nothing but a trapezium. Now the area of this particular region, let's say that the area is A1, that will be half. The formula for area of a trapezium is half sum into half sum of parallel sides into height. Now what will be parallel sides? From here to here, it will be about 6, right? While from here to here, it will be about 4 minus 2, because what is the distance between this, or what is the time gap between this? 2 seconds. Okay. So it will be 6 plus 4. And what is the height? The height is about 8 meter per second. Okay. Into 8. Into 8. And this area will come out to be 40 meter, right? Now let us calculate this area, the small triangles area. Okay. Now this area, which we will call it as a 2, that will be how much? 1 minute. Okay. That will be how much? It will be half base into height. So half base is how much? Base is from here to here, right? So this is 10, this is 6. So what will be the time gap between this? 10 minus 6, which will be equal to 4. So half base is 4. But what is the height? If you can see, then the height is actually minus 5. The height is minus 5. So if the height is minus 5, we have to multiply minus 5 because this particular area will be negative. Okay. So the value will become minus 10 meter. The value will become minus 10 meter. Now, if I want to calculate the distance traveled, right? Now, distance is the sum of areas but in the terms of magnitude. Okay, in the sum of magnitude. So it will be A1 modulus plus A2 modulus, right? So it will be 40 plus 10. That will be about 50 meter. That will be about 50 meter. On the other, okay, I think I did a mistake over here. This will be 2. Sorry for that. Okay, as that is 2, so this will become 32. This will become 32 meter. So sorry for that. 32 plus 10, and that will be about 42 meter. Now, if you want to calculate the displacement, okay, if you want to calculate the displacement, then you have to add the areas with proper sign convention. So it will be directly A1 plus A2. The value of A1 is 32 meter, while the value of A2 is minus 10 meter, and this will be about equal to 22 meter. This will be equal to 22 meter. That means the distance traveled is 42 meter while the displacement traveled is 22 meter. And for my correction, this base, okay, sorry, this base is 4 minus 2, that is equal to 2. By mistake, I wrote it as 4. Okay. Now, from this, our answers are 42 meter and 22 meter, right? Option B. Next. Now, in this particular question, two trains, each of length 400 meter, are moving on two parallel tracks. Okay, so let's say that this is train A. Okay, this is train A. Let's say that the train A is actually moving with 72 kilometer per hour, but 72 kilometer per hour, if you will convert that into meter per second, you just have to multiply 5 by 18. So that will be how much? That will be about 20 meter per second. It will be 20 meter per second. And train B is also moving with the same velocity, that is 20 meter per second. But now if the train if the train B wants to touch train A, then it should accelerate with a value of 1 meter per second square. Now let's say that the original distance between A and B, the original distance between A and B is D, and we have to calculate the value of this D, right? Now what I will do is I will consider object A, or I will consider the train A as my observer. Once I consider train A as my observer, the velocity of train A will become 0. And the velocity of train B, or the initial velocity of train B with respect to train A, will also become 0. Will also become 0. That means the velocity of B with respect to A becomes 20 minus 20, which is equal to 0. So the initial velocity, I should write it down. The initial velocity of B with respect to A is 0, but still B has acceleration. And the relative acceleration will be, the relative acceleration of B with respect to A will again be 1 meter per second square. So we now have the relative velocity, we have the relative acceleration, and let's say that the initial relative distance was D. So which equation should we apply in order to calculate when the train B is going to touch train A? The second equation of motion. And given that the time taken to touch train A is 50 seconds. So let us apply the second equation of motion. We know that the initial velocity, or the initial relative velocity, is 0. So S is equal to ut plus half at square. Ut will straightforwardly become 0. So we will directly apply S, which is D, is equal to half into the relative acceleration, which is 1, into T square. What is T? T is 50. So 50 square. 50 square. So from this, we can straightforwardly calculate the value of D, which is 50 square by 2. And that value will be about 1250 meter. 1250 meter. Option C. Okay. Now, we know that if we multiply any type of scalar to a particular vector, its direction is not going to change, but its magnitude is going to change. Okay, so first let us calculate. So if first let us calculate the magnitude of V, right? So magnitude of V will be root over of 3 square plus 4 square, which is root over of 9 plus 16, root 25, that will be equal to 5. Now the magnitude of CV, which is given in the question as 7.5, is nothing but the value of C, which is a scalar quantity, into the magnitude of V. And that is equal to how much? 7.5 as given in the question. From this, I can write down that C into what is the magnitude of V that we just calculated? C into 5. So C into 5 is equal to 7.5. And from this, it is quite obvious that C will be equal to how much? 7.5 by 5. And it will be equal to 3 by 2, or we can directly write it as 1.5. So the answer is 1.5. Option number C. Okay. Now, let's say that we have a rotating table, okay, and the coin is placed over here. The coin is placed over here. And let's say that the table is rotating in this particular direction with the angular velocity of omega, right? Now, if it is rotating with this particular angular velocity omega, then it will experience a centrifugal force in the outward direction, which is actually a pseudo force. And that will be how much? That will be mr omega square, right? And as we are talking about the critical condition, so it is quite obvious that the limiting friction will be acting over here. Okay. And what is the value of the limiting friction? The value of the limiting friction will be mu into tan, which I will write it directly as mu into mg. Okay. Now, as the ball or as the coin, sorry, as the coin is in the equilibrium condition in the radial direction, I can directly write it as mu mg is equal to mr omega square. Now from this, cancel out, and I can directly write as r omega square is equal to mu g. Now mu is a constant, g is a constant, so this will also become a constant. And if r omega square is constant, that means r is directly proportional to 1 by omega square. This is our main important equation that we will use to our advantage, right? Now, if it is saying that the angular velocity is doubled, that means I will directly write it down as r1 by r2 will be equal to omega 2 by omega 1 whole square. Now, if omega 2 is the double of omega 1, this will become 2 square, right? Which is equal to 4. And from this, R2 will be equal to how much? R2 will be equal to R1 by 4. But what is the value of R1? R1 is 8 centimeter. So it will be 8 centimeter by 4. And that will be how much? That will be about 2 centimeter. And what is the answer? The answer is option D, 2 centimeter. Okay. Now, in this particular question, we have a horizontal circular motion, a uniformly horizontal circular motion. Now, let us first draw the FBD and let us see how the FBD looks like, right? So the ball is over here. The tension will be acting in this particular direction. Mg will be acting in the vertically downward direction. And a centrifugal force will be acting in the radially outside direction. A centrifugal force will be acting in the radially outside direction. 1 minute. Okay. So let's say that the centrifugal force is mv square by r. mv square by r. Okay. Now, what is this r? What is this r that we are talking about? R is actually the radius of the circular motion. R is actually the radius of the circular motion. Okay. Now let's say that this angle is theta. This angle is theta and the length of the string is L. The length of the string is L. From this, I can directly say that sine theta will be equal to R by L, or R will be equal to L sine theta. R will be equal to L sine theta. Okay. Now, let us split the tension into its respective components. Okay. One component will be in the vertically top direction, and one will be in this particular direction, radially inward direction. Now, if I will assume that this angle is theta, then this angle will also be theta. That means this component is T cos theta, while the radially inward component is T sine theta. Okay. Now, let us write down the FBD equations. If the ball is in equilibrium with respect to the radial direction, then I can write down as T cos theta will be equal to mg. And instead of writing mv square by r, I think it would be better if I will use mr omega square. Okay, let us use mr omega square as the centrifugal force. So T cos theta can be written as mg, while T sine theta can be written as mr omega square. Now, if I will divide both the equation, okay, if I will divide both the equation, I will get cos theta by sin theta is equal to mass cancel out, tension cancel out, is equal to G by R. What is R? The value of R is L sin theta. So L sin theta omega square. Now sin theta also cancel out. From this, what is the value of omega? The value of omega will be root over of G by L cos theta. Root over of G by L cos theta. Now we know that time period is 2 pi by omega, right? Time period is 2 pi by omega. So this will come out to be 2 pi into root over of 2 pi into root over of L cos theta by G. And this is your answer. 2 pi root over of L cos theta by G, which is option A. Okay. Now, in this particular question, it is a collision based question. So according to the question, the first ball, whose mass is about 10 kg, is moving with a velocity of 10 meter per second, while the second ball, whose mass is 5 kg, is moving with a velocity of 4 meter per second. And after the collision, the 10 kg block will move with a velocity v1, let's say, while the 5 kg block will move with a velocity v2. Okay. Now, if we want to calculate v1 and v2, the best way to calculate v1 and v2 in a faster way is to directly apply the collision formula. Now, what is the collision formula? Let us first calculate the value of mu12. So mu12 will be m1 minus m2 divided by m1 plus m2. And that will be how much? That will be 10 kg minus 5 kg divided by 10 plus 5, which will be about equal to 1 by 3. So we got our mu12. Now what will be v1? v1 will be equal to mu12 into u1 plus 1 minus mu12 into u2. So that will be how much? That will be 1 by 3 into the initial velocity of the first body is 10 plus 1 minus 1 by 3 into the initial velocity of the second body is 4. And that will be how much? That will be about 6 meter per second. That will be about 6 meter per second. In a similar way, if you want to calculate V2, you'd have to do nothing, but you have to apply mu21 into U2. Okay, you have to replace 1 with 2 and 2 with 1. 1 with 2 and 2 with 1. So mu21 plus U2, mu21 into U2 plus 1 minus mu21 into U1. Correct? Now, if you will apply the formula, what is mu21? Mu21 will be m2 minus m1 by m1 plus m2. So it is basically the negative of mu12. Okay, it is basically the negative of mu12. So this will be equal to how much? This will be equal to minus 1 by 3 into u2. So u2 is the initial velocity of the second body, which is 4. Okay, plus. Okay, so if you will put the values, let me put the values over here. So minus 1 by 3 into u2, u2 is about 4 plus 1 minus of minus 1 by 3, 1 minus of minus 1 by 3 into u1, u1 is about 10. And if you will proceed with the calculation, you will get the velocity as 12 meter per second. You will get the velocity as at 12 meter per second. So what are the answers? The answers are 6 meter per second and 12 meter per second. The option is A. Now, okay. So in this particular question, we have to calculate the change in momentum, right? So if the ball is falling from a height h1, what will be the velocity just before the collision? Just before the collision, the initial velocity, okay, the initial velocity, let me write it as u. The initial velocity just before the collision will be root over of 2g h1, correct? While after rebounding or after rebouncing, if its maximum height is h2, that means the velocity after collision will be root over of 2g h2. 2g h2. That means the change in momentum will be equal to m into final velocity minus initial velocity. So mass is m. Final velocity is definitely root over of 2gh2 in the upward direction. But the initial velocity will be minus 2 minus root over of 2gh1. Why minus? Because the initial velocity is in the downward direction. The initial velocity is in the downward direction. Okay, because it is falling. So this will become, let's take root 2g as common. So this will become m into, or you can just type m into, I will write it directly, m into root over of 2g h2 plus root over of 2gh1. Correct? Now, if we will interchange them, this will become m whole into root over of 2gh1 plus root over of 2gh2, which is the same as our option B. Which is the same as our option B. Okay. Now, in this particular question, a body is falling from a height of 10 meter. It loses 20% of its initial energy, and we have to calculate the coefficient of restitution, right? Okay. First, let us discuss what exactly the definition of coefficient of restitution is. It is the separation velocity minus, divided by the approach velocity, which is u1 minus u2. Correct? Okay. Now, as it is striking with the ground, which has infinite mass, the ground will not move. And if I will consider the ground as my second body, that means V2 and U2 both will become 0. And E will be defined as minus V1 by U1. Minus V1 by U1. Okay. Acha. So what is U1? U1 is the initial velocity. So if it is dropping from a height h, let's say, if it is dropping from a height h, then what will be its initial velocity? Its initial velocity will be root over of 2gh. Its initial velocity will be root over of 2gh, right? Now, after dropping, it is losing 20% of its kinetic energy. It is losing 20% of its kinetic energy, right? So first of all, from where it is dropping? From a height of mgh, right? Sorry, from a height of h. So what will be its initial potential energy? Initial potential energy will be mgh. Okay. Or even if I want to calculate the kinetic energy just before the collision, that will be how much? That will be half m into u1 square, which will be also equal to mg into h. Correct? Now the kinetic energy after the collision is 20%. Okay, 20% of the energy is lost. So how much energy is left? 80%. So 0.8 into the kinetic energy of before collision. So it will be 0.8 mgh, right? Now, if the kinetic energy after collision is 0.8 mgh, that means the velocity will be how much? So kinetic energy after collision, I can write it as half m v1 square, which will be equal to 0.8 mgh. Mass cancel out, and from this v1 will be equal to root over of 2 into 0.8 gh, right? That is our v1. Now finally we can calculate our coefficient of restitution. That will be minus v1 is how much? V1 is root over of 0.8 into 2gh, and u1 is root over of 2gh. Correct? Okay. Now there will be a slight change in this equation. U1, as U1 is in the negative direction, so I have to use a minus sign over here. Okay, because the initial velocity is in the downward direction. Now minus minus cancel out, 2gh cancel out. So our answer comes out to be root over of 0.8. Root over of 0.8. So what is the root over of 0.8? It is about 0.89. It is about 0.89. So what is the value of the coefficient of restitution? 0.89, option number A. Okay. Now, in this particular question, the initial velocity is already given, or the velocity before the collision. Let's say the velocity before the collision is 8 meter per second, but as it is moving in the downward direction, I will write it as minus 8 meter per second. And the velocity after collision is 6 meter per second in the upward direction. Now again, if I want to calculate the change in momentum, it will be mass into the velocity after collision minus the velocity before collision. So mass is how much? Mass is 2 kg. So 2 kg into velocity after collision is 6, while velocity of before collision is minus 8. So the answer will come out to be 2 into 6 plus 8, which is about 28 kg meter per second. Option A. Okay. Now, in this particular question, what we have to do is, as we have to pull it against gravity, that means the work done by us will be exactly the same in terms of magnitude. In terms of magnitude, the work done by us will be exactly the same as work done against the gravity or work done by the gravity. So as gravity is a conservative force, we can directly apply that work done will be nothing but equal to change in the potential energy. Work done will be equal to change in the potential energy. Now work done by conservative force is minus delta U, but as we are working out, so that's why I am taking the magnitude of the work done. Okay, which is equal to delta U. Now let us calculate the value of the potential energies before and after. Now, in the first case, the center of mass of the right side body, which is of the hanging part of the chain, is over there, while the center of mass of this particular part will be over here. Now, if I want to calculate the potential energy of this hanging part, then I will assume that the ground, which is this particular level, okay, this particular level as my base, which means the potential energy at that particular point is zero. Now, as this length, as this particular length is about L by 3, is about L by 3, that's why this particular height will be L by 6. Now that height is in the downward direction, so I should write it as minus L by 6. That means the initial potential energy will be mass of the hanging part. It will be the mass of the hanging part. Now, how much is the mass of the hanging part? So we know that if some portion of a rope is hanged, and the density of the rope is uniform, and the density of the rope is uniform, then that mass will be m into length of the hanging part by the total length, right? So that will be how much? That will be m into L by 3 by L. So that will be m by 3. That will be m by 3. So it will become m by 3 into g into depth. Depth is minus L by 6. Depth is minus L by 6. So this will come out to be minus mgl by 80. Okay. Now, what do you think the final potential energy will be? The final potential energy will come out to be zero because the complete rod is on the ground. The complete rope is on the ground, or the complete chain is on the ground. Okay. Acha. So what is delta U? Delta U will come out to be U final minus U initial, which is 0 minus of minus MGL by 18, and that will come out to be MGL by 80. And that is the work done. So answer is option D. Okay. Now, in this particular question, it is saying that the kinetic energy is getting doubled if the velocity is increasing by 2. That means, let's say that the initial kinetic energy was half mv square, right? Now, this kinetic energy is getting doubled if the velocity is increasing by a factor of 2, right? By a factor of 2. That means two times of the initial kinetic energy is equal to the final kinetic energy in which the velocity has increased by a factor of 2. Correct? Okay. Now, half m cancel out, and I will get 2v square is equal to v plus 2 whole square. Now take a root over on both the equation, on both the sides. This will become root 2v is equal to v plus 2. Then take this v in the LHS, and this will come out to be v whole into root 2 minus 1 is equal to 2. V whole into root 2 minus 1 is equal to 2, or v is equal to 2 by root 2 minus 1. Now, if you will rationalize it properly, then this will become 2 whole into root 2 plus 1 meter per second. Meter per second. Okay. So the answer is option B. Okay. Now, in this particular question, let's say that I'm continuously adding sand in order to make that particular cone. Then there will come a time when the sand will when the first layer of the sand will just start to slip, right? Now, what is that condition? We know that from the uh, angle of friction. Okay, we know that from the angle of repose. Sorry, we know that from the angle of repose, if the value of tan theta, if the value of tan theta on and this theta is the angle between the first layer of the sand and the horizontal. If the value of tan theta becomes equal to mu, then that is the critical condition. If the theta increases even a little bit more, then the cone will fall down, or then the first layer of the sand will start to slip, right? Okay. Now, in this particular case, if you will look at the figure carefully, where theta is the angle of the inclination, then tan theta should be equal to mu. That is absolutely correct. This is the first layer, and mu is the friction between the first layer and the next successive layer. But from the figure, we know that this is 90 degree and this is the height of the cone. Then tan theta is nothing but equal to h by r as well. Tan theta is nothing but equal to h by r. So mu can be written as h by r. Okay. And from this, what will be the value of H? Mu into R. What will be the value of H? Mu into R. Now, what do you think the volume of a cone formula is? It is 1 by 3 pi r square into H, right? But we just found out that what is the value of H? Mu into R. So this will become 1 by 3 pi r square into mu into R. Or we can simply write it down as mu pi r cube by 3. Mu pi r cube by 3. So what is the answer? The answer is option D. Now, in this particular question, which is actually a variable mass related question, what we can do is, let us assume that the upthrust that is produced by the rocket, is F up, right? And as no other forces are acting, that means we will assume that the rocket is in space and gravity is absent. Okay. Now, particles which are the gas particles, okay, or the exhaust gas particles are coming out. Exhaust gas particles are coming out with a velocity of with a relative velocity of v with respect to the rocket. With a relative velocity of v with respect to the rocket, right? Okay, and we will assume that the acceleration of the rocket is a in the vertically upward direction. Now, what do you think the upthrust formula is for a rocket which is losing mass continuously? It is nothing but your relative velocity into dm by dt right? Now, if I will write down the FBD equation, I will get that F upthrust is nothing but equal to the instantaneous mass of the rocket, which is m, into the acceleration of the rocket. Okay. Now, the relative velocity is actually minus v. Why minus v? Because the particles are going in the negative direction. Right? So this will become minus v into dm by dt is equal to m into a. Okay. Now, if I will go for variable separation, then I will get dm by m is equal to minus a by v into dt. Now let us go for the integration part. Okay. Initial mass of the rocket was m naught, and let's say that the final mass is m. While the time taken is from 0 to t. If you will solve the integration part, you will get ln m by m naught is equal to minus 80 by v. And if you know the formula of logarithm, then from here you can directly write it down that m will be equal to how much? M will be equal to m naught into e to the power minus 80 by v with the help of the property of logarithms, right? And the suitable answer for this is option A. Now, this is the question in which we have to apply the concept of the pseudo-force. First, look at this particular velocity. What is the value of the velocity? The value of the velocity is 5t I cap plus 2t j cap. Now, if you will differentiate this, you will get the acceleration. And what will be the acceleration? Acceleration will be dv by dt, and that will come out to be 5 I cap plus 2 j cap. That means the x component of the acceleration is 5 meter per second square, while the y component of the acceleration of the block is 2 meter per second square. Okay. Now, both of them are in the positive x direction and the positive y direction. That means the ball or the solid sphere is going to experience a pseudo force in the vertically downward direction as well as in the horizontally backward direction, because pseudo force always acts in the opposite direction of the acceleration, right? And that value of the pseudo force will be max and may. But along with the pseudo force, the sphere has its own mass, which is mg. The sphere has its own mass, which is mg, that is acting in the vertically downward direction. So what do you think the net force magnitude will be? The net force magnitude will be root over of max square plus may plus mg whole square. One is the x component force, the other one is the y component force, right? So I will take the mass common. And this will turn out to be ax square plus ay plus g whole square, ay plus g whole square. So what is the mass? The mass of the body is about 2 kg. So 2 into root over of ax is 5 meters per second square. We just calculated. So 5 square plus ay is 2 and g is 10. So 2 plus 10 whole square. And after the calculation, you will find out that the value of the net force is about 26 Newton. About 26 Newton. So what is the correct answer? Option C. Okay. Now, in this particular question, the external force that is acting on the block in the horizontal direction, that force with respect to time graph is already given. Okay, but we know that friction will definitely be acting, right or not? And which friction will be acting? Kinetic friction will be acting. So first, let us calculate the value of the kinetic friction. Okay, first let us calculate the value of the kinetic friction, and then we will get to know. Then we will get to know when the object is actually going to move. So the value of the friction will be mu into n, mu into mg, where normal action is mg or its own weight. Now, what is the value of mu? Mu is 0.6. Mass is 20 and gravity is 10. So it will be about 120 Newton. It will be about 120 Newton. Okay. So until and unless the force becomes greater than 120 Newton, the block is not going to move. The block is not going to move. So what you should do is you draw a straight line depicting the limiting friction or the kinetic friction. Now, until and unless this force goes over this, the body is not going to move. The body is going to remain stationary, right? The body is going to move, body is going to remain stationary, right? So now what we are going to do is we know that 120 Newton out of the complete force, okay, out of whatever force the body is experiencing, out of all that force, 120 Newton force or 120 Newton amount of force will be used up for the body to start to move, right? That means for a force versus time graph, if we will calculate, if we are going to calculate the area of this much portion, if we are going to calculate the area of this much portion, then we will get the actual impulse. Okay, because out of the complete force, 120 Newton amount of force is getting used up by the friction, is getting used up by the friction, right? So let us calculate the impulse. Let us calculate the impulse by calculating the area. Let's see. So the area of that particular picture, which is nothing but your impulse or change in momentum, which is nothing but your impulse or change in momentum, which is also area. So area of that trapezium will be half into sum of parallel sides. So let us first calculate what will be the sum of parallel sides, right? Now we know that this is a straight line, okay? And I want to calculate at what particular time, at what particular time is 120 Newton being achieved, okay? So first let me calculate the slope of the graph. So what will be the slope of the graph? The slope of the graph will be 200 by 5, 200 by 5, which is about 40, which is about 40. Okay. Now, what will be the line equation of that graph? It will be F is equal to mt. F is equal to mt, so which will be equal to 40t. Now, if I want my force to be greater than 120 Newton or to be 120 Newton in order to counteract with the friction, then at what time are we getting that much amount of force? That will be 120 by 40, and that is equal to how much? That is about 3 seconds. That is about 3 seconds. That means this time is 3 seconds, right? Okay. Now, sum of parallel sides, which is this is and this, right? So first let us calculate this particular time interval. This is 10, this is 5. So what do you think the time interval between this to this will be? 5 seconds. 10 minus 5, 5 seconds. So one of the parallel side is 5 seconds. While the other one from here to here, okay, sorry, from here to here, this much is 5 seconds, which we just calculated, while this much will be 5 minus 3, that is about 2-second time interval. So total time interval will be how much? 2 plus 5 seconds, that will be 7 seconds. That will be 7 seconds. So half 5 plus 7, half will into 5 plus 7 into the height. Okay. Now, which height are we talking about? We are talking about this particular height, right? We are talking about this particular height. So this is 200 Newton. This is 120 Newton. This is 200 Newton and this is 120 Newton. So what do you think this particular height will be? That will be 200 minus 120, which is about 80, which is about 80. So the height is 80. The height is 80. And from this, the impulse will be how much? The impulse will be 40 into 40 into 5 plus 7. 40 into 5 divided by 40 into 5 plus 7, which comes out to be 480, which comes out to be 480 Newton second. Okay. Now, if I want to calculate the velocity, I will just apply impulse is nothing but change in momentum. Now, initially it was rest, so the initial momentum will come out to be zero. And the final momentum is mass of the body into the final velocity. And the final velocity is what we want to calculate. The final velocity is what we want to calculate. And what is the mass of the body? 20 kg. The mass of the body is 20 kg. And from this, the final velocity comes out to be 480 by 20. That is about 24 meter per second. 24 meter per second. The answer is option A. Now, this question is based on basic mathematics. Okay, so let us solve this as quick as possible. Now, 1 by tan A. Tan A I can write it as sin A by cos A. And cot A I can write it as cos A by sin A. Now, let us take LCM. If you will take LCM, then this will become sin square A plus cos square A divided by sin A cos A. Divided by sin A cos A. Now sin square A plus cos square A is 1 and sin A cos A will go into the numerator. So the answer will come sin A into cos A. The answer will come sin A into cos A, which is option B. Now, in this particular question, it is said that the power that is delivered is constant, right? So we know power is given as force into velocity. And force is given at mass into acceleration. So it will be mass into acceleration into velocity. And acceleration can be written as dv by dt. dv by dt. As power is constant, I can write down as m into v dv is equal to p into dt. Okay, is equal to p into dt. Now let us go for integration. Let us go for integration, right? Okay. So we will assume that mass is constant. Obviously, the mass will be constant and the integration will turn out to be v square by 2. Now, what will be the limits? The limits will be initial speed is 0 and we want to calculate the speed after 5 seconds. So the final speed is v, let's say. So mv square by 2. Okay, the left hand side will become mv square by 2. And the time is going from 0 to 5 seconds. Okay, 0 to 5 seconds. So this will be p into t and the limits is from 0 to 5. The limits is from 0 to 5. Okay. Achha. Now, what is the mass of the body? 0.2 into v square, which we want to calculate. V is the thing that we want to calculate, is equal to power. Power is about 0.5 and time is about 5. Now, if you will solve this equation, you will get v is equal to 5 meter per second. V will be equal to 5 meter per second. Okay. Now, okay. So first, from this loss of kinetic energy, which is 75% of the kinetic energy is lost, that means how much kinetic energy is being left or how much is the final kinetic energy. So I can say that the final kinetic energy will be as 75% is lost. So how much is left? 25%. And 25% means 25 by 100, which is also equal to 1 by 4. So the final kinetic energy can be written as the initial kinetic energy by 4. But we know that kinetic energy is directly proportional to V square, right? So from this, V final square will be equal to V initial square by 4, or V final will be equal to V initial by 2. V initial by 2. That means the final velocity is half of the initial velocity. And from this, it is straightforward that the coefficient of restitution will be how much? 1 by 2. The coefficient of restitution will be 1 by 2. Okay. Once you get the coefficient of restitution, then calculating the distance will is straightforward. We will directly apply the formula in this particular case of repetitive bouncing back. And that formula is the distance traveled is equal to the initial height. The initial height multiplied by 1 plus e square by 1 minus e square, where e is nothing but your coefficient of restitution. So what is the initial height? Initial height is 3. So 3 into 1 plus 1 by 2 square, which is 1 by 4, by 1 minus 1 by 4. 1 minus 1 by 4. And this will come out to be 5 meter. This will come out to be 5 meter. So the answer is 5. Next. Now, in this particular question, we can straightforwardly apply the formula. So already the formula for range for inclined slope, we already know what that formula is. And that formula is, so let's say I will just name the variables. Let's say that this angle is alpha, this angle is theta, then this particular angle will also be alpha, right? Okay. Now, the formula of range is 2u square cos theta into sine of theta plus alpha into sine of theta plus alpha divided by g cos square alpha divided by g cos square alpha. So now let us straightforwardly apply the formula and get our answer. So what do you think the range will be? The range will become 2 into u is 10. So 10 square cos of theta, theta is 60 degree into sine of 60 plus 30, which will become 90 divided by g. G is again 10 into cos square alpha. Alpha is 30. Alpha is 30. Okay. Now, if you will proceed with the calculation, you will get the answer to be about 13.33 meter. 13.33 meter. And if you will round it up, the answer will come out to be 13. So answer is 13. Next. Now, in this particular question, we are doing some work in order to lift the rod, which is actually pivoted with respect to the ground, Okay. Now the center of mass of initial center of mass of the rod is over here and the final center of mass of the rod is over here. Let's say that this particular height till which the center of mass is being risen up is small h. Okay. But what do we have to calculate in the question? In the question, we have to calculate the value of capital H, which is how much the point B is going up, right? Okay. Now, as we are doing work against gravity, that means no non-conservative forces are acting. So we can assume that the work done by us will be again change in potential energy. Okay. So the magnitude of work done by us will be the magnitude of change in potential energy. Okay. So initial potential energy is 0 because of the complete rod is on the ground, while the final potential energy will be mgh. That means the work done is mg into small h. Okay. And according to the question, the work done is already given, which is about 100 joule. So from here, we can write down that 100 joule is equal to m. M is 10 and g is also 10 into h. So 100 and 10 cancels out. And from here, the height of the center of mass comes out to be 1 meter. The height of the center of mass comes out to be 1 meter. But we don't want to calculate height. We want to calculate the height of point B. Now let us assume that this angle is theta. Okay. Now from and what will be this value? 1 minute. Okay. So let us assume that that particular height is theta. And with the help of midpoint theorem, actually, that is actually a very good way to approach with this. With the help of midpoint theorem, which is the triangle's midpoint theorem, we know that this center, the center of the mass is exactly at the middle of the rod. Okay. And this point is also exactly at the middle of the shadow of the rod. Okay. Because gravity is acting very symmetrical across the rod. So we can directly write with the help of midpoint theorem that h will be nothing but equal to twice of small h. Okay. So finally, we can say that the height at which the point B has been reached is about 2 meter. Is about 2 meter. So answer is 2. Now, the last and the final question. In this particular question, no friction is acting. Even though normal action is acting, the work done by the normal action will be 0. That means basically we can say that no non-conservative forces are acting over here. If non-conservative forces are not acting in this particular question, we can easily apply our conservation of mechanical energy. And that is what we are going to do. The ball is being released at A. As it is being released, its initial velocity is 0. So I can say that the total mechanical energy of the ball will be the initial kinetic energy. The total initial mechanical energy of the ball will be the initial kinetic energy, but the initial kinetic energy will be 0 plus the initial potential energy, and that will be how much? That will be 2 mg or mg into h, right? Mg into h. Height is how much? Height is 2. So I will directly write it as 2 mg. Correct. Now, in the case of final total mechanical energy, I will assume that it attains a velocity v. So the final kinetic energy will become half mv square, while the final potential energy will be mg into 1. mg into 1. Now, if I will apply conservation of mechanical energy, I will write down half mv square is equal plus mg is equal to 2 mg. Now, m cancels out. From here, I will get v square by 2 is equal to 2g minus g, which will become g, or v will be equal to root 2g. Oh, wait. So we just have to calculate the kinetic energy. I thought that we have to calculate the velocity. Absolutely sorry for that. So let's say that the final kinetic energy is kf. Final kinetic energy is kf, or I can say that that is kp. Okay. Now again, if I will apply conservation of mechanical energy, kp plus mg will be equal to 2 mg. Kp plus mg will be equal to 2 mg. So what do you think the value of the kinetic energy at the final position is? It is 2 mg minus mg, which will be equal to mg itself. Now mass is 1 kg, gravity is 10, so that will be about 10 joule. That will be about 10 joule. So the answer is 10. Finally, the paper is over. I hope that you liked my paper discussion, and all the best for your future part test. Chalo, tada.